Hello everyone, welcome to Ed School. Today we are going to understand about image formation by a concave mirror. So if you haven't understood the previous video to it, you should watch that first. Why? Because over there are some rules for formation of a image in the mirrors that you have to understand, then you can already understand this thing. Okay. Now the first step, or we could say the first scenario is not this step, but the scenario is that when the object is at infinity. So your object is at infinity. What can be the objects at infinity? You can consider anything. For example, a sun, a moon, let's say star. All of these objects are technically at infinity, right? At infinite position. So we will considering about those kind of objects which are at the infinite for once. Let's consider this AB row. You see this AB is actually the object, and now we are going to form an image out of it. How will be the image formed? You see, from the rules we have studied this thing, that if any line which is parallel to the principal axis, you see this ray which I have just darked out right now is parallel to the principal axis. Which one is the principal axis? This black one is the principal axis, of course. So if there is any line which is passing through the principal axis, parallel to the principal axis, sorry, then it will be reflecting back from the mirror, and after reflection it will be coming on the focus. Similarly, we have considered any one more ray which is starting again from the object, and then it is reflecting, and after reflection it is coming at the focus. So if we understand about the property of these kind of images, what are the property? The first property of this kind of images is that image is formed at the focus, at focus. You can see, yes, your image is formed at the focus. Then the second one is that you see, if I talk about any object which is at infinity, then let's consider that object is very, very large. But will the image also formed as large? No, that image won't be large. The image you will be getting will be very, very small in comparison to that of the object. That's why we say the image which is formed in this case is very small in compared to that of the object. Which kind of image is it? Is it real or virtual? It is a real image. Why? Because it is formed at the same side as that of the object, or you could say it is in front of the mirror, not in the back side. That's why. Also, this image which will be formed will be inverted image. We will understand about the inverted in the next scenario. Let's move to that one then. So in the next scenario, what is happening? That when the object is beyond the center of curvature. Now, if you do not know what is center of curvature, let me quick tell you that the center of curvature, first of all, is if I measure from the pole, then the center of curvature's length is just double that of the focus, first point. Second thing, you see that this spherical mirror is a part of a hollow sphere. It is a part of a hollow sphere. So in that case, we have just cut up a small portion, and here we form the spherical mirror. This is the spherical mirror. So you see, for this sphere there must be some center, and then there must be some radius. So the center point is named as the center of curvature, and then from the center of curvature to the pole, this distance will be named as the radius of curvature. Okay, now see, all of these topics are being already explained in the previous videos, so if you are watching one by one, it is better. Okay, now the second point is that when the object is beyond the center of curvature. What if it is beyond the center of curvature? See, it is not at infinity in this condition. It is like it's not very at very large distance from that of the pole, but the scenario is it is just beyond the center of curvature. In that case, again, I'm making one line which is parallel to the principal axis, then it is reflecting, and after reflecting, the parallel line will always pass through the focus. This was the first rule when we were understanding that if there is any ray parallel to the principal axis, after reflection it will be passing through the focus, and you see it is passing out. Then the second ray is passing through the center of curvature. I have told you in the rules this thing that if any line is passing through the center of curvature, or we could say any ray is passing through the center of curvature, that will retrace its path. It means from wherever it was coming, it will be going back in the same direction, and also on the same path. Okay, so in this condition, if I want to see where is my image formed, my image is formed when the two reflected rays are intersecting. Where are they intersecting? They're intersecting at this very point. So this point will be the one where the image formation will take place. Now let's understand about the property of this kind of image. First of all, this is formed in between the focus and the center of curvature. You see, this is the focus point over here, F, and C is the center of curvature, and your image is somewhere between the C and F. Okay, in that case you can see the image is also inverted, isn't it? It isn't it opposite like this, so it's inverted. Then again it is a real image. Why real? Because again it's formed in the same side as that of the object. Unless it is formed on the same side as that of the object, it will be considered as the real image. Then what about the size? If you will see in the image also, the size is a little smaller than that of the object. So size is smaller than that of the object. Let's move to the next scenario, that is when the object is at center of curvature. When the object is at center of curvature, at that time you will see that one ray, again I'm saying this thing again and again, I'm repeating, one line which is parallel to the principal axis will be reflecting back and will be passing through the focus, and that's what happening over here. What about the next one, or what I can say is, what about the next ray? The next ray is passing through the focus and then it is reflecting back. So this was the third rule which we have studied, that is if any ray is passing through the focus, see this one is passing parallel to the principal axis and then reflecting from the focus and reflecting from the focus, while this one is incidenting on the focus and then reflecting back parallel. Right, in this case, where will be the image formed? The image will be formed where the two rays are intersecting to each other. In this case, what are the properties? The property is that the image is formed at the center of curvature. See, the object was also at the center of curvature and the image is also at the center of curvature only. This is again a real image. Why real? Because again it is formed on the same side as that of the object. Then it is inverted. You can see this is inverted image. Then the third point is that it is same size as that of the object. Previously we were understanding that it is smaller and smaller, but now we see that it is at the same size of that of the object. For example, if your object is 4 centimeter long, then your image will be also 4 centimeter in this case. Then the next is when the object lies between the center of curvature and the focus. So this one is center of curvature and this is the focus, and we see that our object is lying in between. So in this case, again, two lines, one will be passing parallel to the principal axis, which is passing through the focus. Then one is going on and reflecting back from the mirror. And when we extend it up, see, I'm saying it again, that one line is passing to the mirror and then it is reflecting back to the same path. So when we will extend it up, it seems like it is passing to the center of curvature. When you will see that where these lines are intersecting, so let's say at this point they were intersecting, you can just make up the object. What are the property of this image? First of all, this is formed beyond the center of curvature. This is formed beyond the center of curvature. It means just after the center of curvature anywhere. Then it is a real image again. Why? Because though object is over here and the image is over here, doesn't matter, they are still on the same side. That's why. Then image is bigger than that of the size of the object. Image, you can see the image is larger and the object is smaller. Okay, the next scenario is when the object is at focus. See, when the object is at focus, it is on the focus only. So when it is on the focus, again the two lines, one which is parallel to the principal axis, which will be passing through the focus. Then other one, the same scenario as that of the previous one. One line which is starting from the object, going to the mirror, coming back from the same path, and then passing through the center of curvature. We see that these two lines are parallel to each other. It means they will never meet somewhat. So we say that the image in this case will be formed at infinity. What are the properties in this case? The property first is that formed at infinity, the image is formed at the infinity. Is it real? Yes, it is real. So what if it has infinity? Still, it is on the same side as that of the object, so it is an infinity. Then it is inverted. Yes, it is inverted. Much larger size as that of the object. The object is very small in this case, while the image which will be formed will be very, very large. Okay, then the last scenario is that when the object is between focus and pole. When the object is in between focus and pole, so what you're doing now, you're moving away from the focus or towards the pole. You're moving towards the pole. In this case, you see one of the ray is again going towards the mirror, reflecting back from the same path. So we just extend it up from the center of curvature. First thing. Second thing, what is happening, that we are making a ray which is going on the pole, and hence it is reflecting back, making an angle of incidence and reflection, which two are equal to each other. This we have understood in the rules, first of all. And second thing, this is also the law of reflection, one of the law. Okay, in that case, what we are doing over here, these two lines doesn't seems to ever join. So for that, what do? We just extend them up backward, or we could say behind the mirror, and we find out that over here is the image. What are the property in these cases? That first of all, it is formed behind the mirror. Okay, then second thing, this is virtual. Till now we were understanding about the real image. Why real? Because they were formed at the same side as that of the object. But in this case, you see, the image is formed behind the mirror, so this image will be called as the virtual. Is it erect? Yes, it is straight. See, it is straight and it is erect, it isn't inverted. Now image is larger than the size of the object. You see, the object is very small, right, AB, while our image is larger, that is A dash B dash. Now this is a summarize for all of them, that is position of the object, then position of image, and the nature of the image. First of all, when it was in infinity, the position of image was at the focus. Then it was real, point, image, and inverted it was. Beyond the center of curvature, it was between the focus and the center of curvature. This you will understand by the regular practices. You can just go through this, and you can take a snip or anything you want, and you can keep it with you. It will be helpful for you for the revision. This table will be helpful for you at the time of revision. Okay, now you can also see one important thing, like it's not important, but I could just tell you one thing, that one thing you can observe is that as you are bringing the object, see, I will say this thing, that as you are bringing the object close to pole, right, it's just a observation thing, that as you are bringing the object close to the pole, your image is moving far away from the pole. Image is moving far from the pole, far from pole. If you can observe this thing, it's fine, otherwise it's not there anywhere, so you can just skip this part. I was just telling you for the knowledge. Okay, now the image formation by the convex mirror, which we are going to understand in the next video. Thank you for watching.